So I hope you have went through the previous video which I've already sent in the group. So following that, we have exercise 3.4 question number 1. So here tan x is equal to root 3 and we have to find the principal and general solutions. Now principal solution is what? In which the solution means the value of x must lie between 0 and 2 pi. So whenever the value of x lies between 0 and 2 pi, that will give you the principal solution of that trigonometric equation. So for principal solution, what we see is that the value of x must lie between 0 and 2 pi. Now the next thing is, what we need to do is, for principal solution, the first thing I have tan x is equal to root 3 in here. So now we need to think of the angles for which tan x gives the value root 3. So for the first moment I will check the sign. So here the sign of root 3, it's plus sign, it's not negative. So then we think of in which two quadrants tan x is positive. So if I draw the quadrant here, and we know that in the first quadrant all positive, in the second quadrant sine, third quadrant tan, and fourth quadrant cos. So we can see is that the tan is positive in the first quadrant and in the third quadrant. So the basically what we see, the angle must lie in the first quadrant and the third quadrant. The first quadrant angle will be what? It's quite familiar. We're quite familiar with that one because we know that tan 60 degree is root 3. So the first angle or the first solution of this question is pi by 3. So x value will be pi by 3. That's the first principal solution. And for the second principal solution, what we have is the value, the angle must lie in the third quadrant. Now one thing, this much angle, the angle made by the line with respect to x-axis, it will be pi by 3. So that thing, this angle will be pi by 3. But that is not my actual angle. The actual angle starts from the positive direction of x-axis. This one is the positive direction of x-axis and like this way. So this is my actual angle. So the value of actual angle will be how much? It will be this one will be, here you see, so this much angle, that is pi, so it will be pi plus pi by 3. So the other angle will be pi plus pi by 3, and that is basically equal to x is equal to pi by 3, and this comes out to be 4 pi by 3. So these two are the principal solution of our given trigonometric equation. Now we need to find the general solution. Now for general solution, I have given the derivations of each one of them. For sin x is equal to sin y, cos x is equal to cos y, and tan x is equal to tan y. So for tan x is equal to tan y, what we see is that, so what we're going to do here, I don't see tan y, so here I see what? Root 3. So first I will write that one in the form of tan x is equal to tan y. So tan x is equal to, in place of root 3, what I'm going to do is I'm going to write the smallest angle for which tan is root 3. So you see from here we have already found out that smallest angle is tan pi by 3. So I'm going to write here tan pi by 3. Now if we recall the formula when tan x is equal to tan y. So tan x is equal to tan y. So this gives us x is equal to n pi plus y. So this is the formula. This is the general solution of the trigonometric equation of the form of tan x is equal to tan y. So here we can directly write. So the general solution will be, the general solution is x is equal to n pi plus pi by 3. So this is my general solution, and the principal solution is pi by 3 and 4 pi by 3. Like the same way, sec x is equal to 2. Now sec, cosec, then cot, these are confusing. So basically it's not easier to determine the values of sec, cosec and cot. So what I do is we try to convert them in their familiar forms. Like sec, we can convert it in cos x form. Now sec x is what? Reciprocal of cos x. So here if I change this sec x into cos x, so this 2 will become 1 by 2. It will become reciprocal of 2. So now cos x is equal to half. So I hope this one you can easily complete, because cos x is equal to half, I will check for which angle cos x is half. So first it must lie in the first quadrant and fourth quadrant. because cos x is positive in first quadrant and fourth quadrant. Then I think of cos x is half is for angle 60 degree again, and the fourth quadrant one will be what? I will just find out. The fourth quadrant one will be, so here we have the first quadrant one, and here we have the fourth quadrant one. For the first quadrant one, the angle will be pi by 3, again 60 degree, because 60 is half. So the principal solutions will be pi by 3, and the other one will be, this one is how much? This one is pi by 3. Okay. Now don't confuse this thing with the argument of a complex number. In argument, we used to do for minus pi to pi, right? But don't confuse this one with that. This is from 0 to 2 pi. This is not complex number. This is trigonometry. So here, this angle is how much? It's pi. But my actual angle always starts from the positive direction of x-axis. So this is my actual angle, this much. So how much is my actual angle? So if you look carefully, this entire thing is my complete angle, and complete angle is how much? It's 2 pi. So the angle is pi by 3 less than 2 pi. So I will do 2 pi minus pi by 3. So it is pi by 3 less of 2 pi, right? So the other solution of this one will be 2 pi minus pi by 3, and that comes out to be the principal solutions. Principal solutions comes out to be pi by 3, and here we have as 5 pi by 3. So these are how we get the principal solutions. Now cot x, again I told you cot x, we don't want to do that. We want to convert it into the familiar one, that is tan x, and that gives us minus 1 by root 3. Now for this one, here we have a negative sign. So now we need to think of in which two quadrants tan x is negative. So tan x is negative in second quadrant and fourth quadrant. So these two quadrants tan x is negative. Now once we denote that the position of the angles, now we think of tan x is 1 by root 3. For what value? It's for 30 degree. So this angle which is made with the x-axis, this one is your 30 degree, and this angle with again made with the x-axis is 30 degree. But these are not my actual angle. My actual angle will be what? My actual angle will be, this one is my actual angle, and that angle we can find by pi minus pi by 3, and the other angle we can find by 2 pi minus pi by 3. So one will be pi minus pi by 3, and the other one will be 2 pi minus pi by 3. So the one will come out to be 2 pi by 3, and the other one will come out to be 5 pi by 3. So these two are the principal solution of this given question. Okay, and the general solution of this one will be just like the previous one. I will take the smallest angle. So smallest angle is 2 pi by 3. So I am going to write this one as tan x is equal to tan 2 pi by 3. Tan 2 pi by 3 is minus 1 by root 3, right? I will always take the smallest angle. So 2 pi by 3 is smaller than 5 pi by 3. So I am taking that thing, and therefore general solution will be equal to what? General solution is x is equal to n pi plus 2 pi by 3. So that's my general solution. As a previous one, I haven't done the general solution. Let me do that one. So cos x is equal to half. So for the smallest angle cos x is half is cos pi by 3. So cos x is equal to cos pi by 3. So if you go through the derivations of the previous video, so there you will find that x will be, the general solution will be x is equal to 2n pi plus minus pi by 3. And that will be the answer. So this is how we find the principal solution and general solution of these simple trigonometric equations. Now the fourth one will be homework for you guys. So what you need to do is you need to convert the cosec functions into sin x function. Now let us do question number 5. The question number 5, what we have is cos 4x is equal to cos 2x. The cos 4x is equal to cos 2x. So how are we going to solve this one? Now again, this equation is directly in the form of cos x is equal to cos y. So once we see this one in the form of cos x is equal to cos y, we can directly use the formula. You see, whenever we see cos x is equal to cos y, what we used to write? So we write x is equal to 2n pi plus minus y. like this. But here cos 4x is equal to cos 2x. So think of 4x as the x. So this 4x as the x and this 2x as the y. So wherever you have x you write 4x, and wherever you have y you write 2x. So I'm going to have here, so general solution or means the values of x will be 4x is equal to 2n pi plus minus 2x. But since the general solution is finding the value of x, so this equation is not complete, this problem is not complete yet. So from here we'll get two equations. One will be 4x is equal to 2n pi plus 2x, and the other one will be 4x is equal to 2n pi minus 2x. So from the first one, what I'm going to do is we're going to get 2x is equal to 2n pi. So therefore x is equal to n pi. And for the second equation, what I'm going to get is 6x is equal to 2n pi. So therefore x is equal to n pi by 3. So these are the two general solutions of my given problem. Now what we're going to do is, let us do question number 6. So in question number 6, what we have, cos 3x plus cos x minus cos 2x is equal to 0. So for these type of questions, now in here we don't have two trigonometric functions, we have three trigonometric functions. So what we need to do is we need to apply formulas in two trigonometric functions such that from those two I get the third term. So if I look at here cos 3x and cos x, now if I use the formula of cos a plus cos b, so the formula of cos a plus cos b is 2 cos a plus b by 2 and cos a minus b by 2. So if you see a plus b by 2, that is 3x plus x, that is 4x by 2, that gives us 2x. So you see I can get cos 2x. So my main motive of getting of doing these type of questions is to get the third term by using formula of the other two terms. So here what I'm going to do is, so 2 cos 3x plus x by 2 cos 3x minus x by 2 minus cos 2x equal to 0, or 2 cos 2x cos x, that is 3x minus x is 2x, so 2x by 2 is x minus cos 2x equal to 0. So if I take the cos 2x common, so we have 2 cos x minus 1 equal to 0. So from here, just like quadratic equations, what we used to write is, so this is basically product of two different terms, and product of two different terms can only be 0 when each of them must be 0. So either cos 2x equal to 0 or 2 cos x minus 1 equal to 0. Okay, so now cos 2x equal to 0. Now we need to find the general solution of these two separately. So cos 2x equal to 0, what we're going to do is, so we need to think of when does cos x become 0. So cos x becomes 0 if you look carefully. Cos x is equal to 0. For what values of x cos x becomes 0? So now we know that cos x is 0 at 90 degree, cos x is 0 at 270 degree, cos x is 0 at 450 degree. So like this way, if you look here, there is a pattern that's originating in here, that is for every odd multiple of pi by 2 cos x becomes 0. For every odd multiple of pi by 2 cos x becomes 0. So x will be odd multiple of pi by 2, odd multiple of pi by 2. Now how do we express odd numbers? We express odd numbers as 2n plus 1, to 2n plus 1 pi by 2. So here the general solution of this one will be 2x is equal to 0. I will write 2x is equal to 2n plus 1 pi by 2. So from here, therefore x is equal to 2n plus 1 pi by 4. Now this one, 2 cos x minus 1 is equal to 0. Now this questions we have already done. So we can write here cos x is equal to 1 by 2. You take that minus 1 that side, it will become plus 1. Then 2 that side, it will become 1 by 2. Now this type of problem we have already done. So what we need to do is we need to write cos x is equal to the smallest angle for which cos x is half, and that is cos 60 degree. So sorry, it will be pi by 3. So here we're going to write here x is equal to 2n pi plus minus pi by 3. So that's my solution of this entire question. Now in case of question number 7, I will just show you how to start with it. So in question number 7 we have sine 2x plus cos x equal to 0. So here you see sine 2x, from the very formula of sine 2x we have 2 sine x cos x plus cos x equal to 0. So from here we can take cos x common and you get 2 sine x plus 1 equal to 0. So either cos x equal to 0 or 2 sine x plus 1 is equal to 0. So like this way you will get the two different trigonometric general solution of the trigonometric equation. Now let's move on to question number 8. Question number 8, what we have is sec square 2x is equal to 1 minus tan 2x. Now here we have two different functions. One is sec square 2x and one is 1 minus tan 2x. So what we are about to do in here is we'll try to convert that sec square 2x into tan 2x form. So you know on trigonometric identity, that is sec square theta minus tan square theta is equal to 1. So from here sec square theta is what? It is 1 plus tan square theta. So in place of sec square 2x I will write 1 plus tan square 2x is equal to 1 minus tan 2x. You're going to write like that. Now we'll arrange this one. So you will get what? Tan square 2x plus tan 2x, and this 1 gets, actually what happens is that this 1 gets cancelled, right? You see this 1 gets cancelled. So what we have, tan square 2x plus tan 2x is equal to 0. Now we can take tan 2x common. So you get tan 2x and you have 1 plus tan 2x plus 1. It's the same thing. Tan 2x plus 1 equal to 0. We cannot cancel tan 2x in here. You see tan 2x from both sides. We cannot cancel that. We have to do like this. So either tan 2x is equal to 0 or tan 2x plus 1 equal to 0. So tan 2x is equal to 0. So when does tan x becomes 0? Cos x becomes 0 when x is equal to 2n plus 1 pi by 2. So when does tan x become 0? So for this one, what we need to do is I need to write here tan x as sin x by cos x. So tan x becomes 0 when sin x becomes 0, because cos x cannot be 0, because if cos x becomes 0 the entire thing becomes undefined. So tan x only becomes 0 when sin x is 0. So all I need to find is when does sin x become 0. So sin x becomes 0 when x is equal to 0, when x is equal to 180 degree, when x is equal to 360 degree, when x is equal to 360 plus 180, that gives us 540 degree. So like this way what we see is that these are nothing but integral multiples of pi. So for every integral multiple of pi, sin x becomes 0. So x is equal to integral multiple of pi. And how are we going to write this one? So integral multiple, I will write this one as n pi. So here it will be 2x is equal to n pi, therefore x is equal to n pi by 2. And in this case tan 2x is equal plus 1 is equal to 0. I'm going to write this one as tan 2x is equal to minus 1. And now we're going to think of for what is the smallest angle where tan x is in minus 1. So negative means it must lie in second quadrant or fourth quadrant. But fourth quadrant I don't need, because I need to have the smallest angle. Now forget the minus sign and think of tan theta is 1 for what value? It is pi by 4. So my angle is what? Pi minus pi by 4. That's my actual angle. Pi minus pi by 4, and that comes out to be 3 pi by 4. So you're going to write this one as tan 2x is equal to tan 3 pi by 4. So 2x is equal to n pi plus 3 pi by 4. So therefore x is equal to n pi by 2 plus 3 pi by 8. That's my answer. Now as for question number 9, what we have is sine x plus sine 3x plus sine 5x is equal to 0. Just I told you beforehand, it is just like question number 6. We need to find two trigonometric functions and we need to use formulas among them such that we can get the third term. So if you look here, so sine 5x and sine x. So if I arrange them like this, sine 5x plus sine x plus sine 3x equal to 0. Now if I use the formula, what we get in here is 2 sine 5x plus x by 2, then cos 5x minus x by 2 plus sine 3x is equal to 0. So from here we have 2 sine 3x cos x, sorry, it will be cos 2x, then plus sine 3x equal to 0. So I'm going to take sine 3x common. So if I take sine 3x common, just like before we have, which we have already done. So from here we can get that either sine 3x equal to 0 or 2 cos 2x plus 1 equal to 0. And we have already found out that where does sine x become 0? Sine x is equal to 0 when x is equal to n pi. So here sine 3x is equal to 0. So 3x is equal to n pi. So therefore x is equal to n pi by 3. Now cos 2x plus 1 is equal to 0. So I'm going to write this one as cos 2x is equal to minus half. So what is the smallest angle for which cos x is minus half? So it must be in second quadrant or third quadrant. But I don't need the third quadrant one, I need the smallest one. So it is the second quadrant. Now forget the minus sign. So cos x is half for what value? 60 degree. So this angle is your pi by 3, but my actual angle is pi minus pi by 3. So that comes out to be 2 pi by 3. So it will be cos 2x is equal to cos 2 pi by 3, and that's 2x is equal to, the general solution will be 2n pi plus minus 2 pi by 3. So therefore x is equal to n pi, if I divide by 2, it will be pi by 3. So that's how we solve the trigonometric equations.